Okay, yes, you are right. Nathan is a wonderful person. All right, let's get to our notes. If you're not quite done, finish that first, please. I'm not trying to rush you, but we are going to run out of time. Is anybody still doing the survey?
Yeah.
Yeah.
Okay. That's allowed. I will allow it. Almost gonna open the door. Nathan, I started recording. I shouldn't have, but now that I have your attention, please do that little survey that's on Classroom after you get your test back. Don't worry about it right now. Pretty please. Okay, is anybody still writing?
Yeah, I'm almost done.
Is it just shorthands? Are you writing, Ben, or are you done?
I'm thinking.
You are still writing?
Yeah.
Okay,
This is a good reflection.
good. Like what you're writing or the questions? I just right away assumed it was you were complimenting me. Oh, thank you. Oh, wait, what? You can't read that?
You really, I need glasses. You really. Yeah, I do.
There are some closer seats.
Yeah.
Yeah,
Yeah.
then I'd have to move.
Begin to squint.
What did you say, Kate? Your eyesight's gonna die? Oh, well, she's got this thing over her face. I was like, how rapidly are you going blind? She got these glasses yesterday, but last week. Yeah, don't, this isn't notes yet.
We did this on.
This is, yep,
Sorry, bad time.
yep. So I just have it here to see if there was any questions anybody wanted me to go over. Because this was the last day's assignment. No? Cool. If there was, I was gonna say I was just gonna record them and post them because we're running out of time. Motion in 2 dimensions, same thing we're doing yesterday, except today we're doing it with calcumulators and pens and pencils, and not pens, just pencils and calculators. Some sketches. What did you do? There will be, when it comes to test time, you will need to do these both ways. One through scale diagram, one through algebra. You will hear me say for the next, I was gonna say 2 years, I'm not here next year. For this semester, we were talking a lot about component vectors. So these are the vectors that kind of make up horizontal and vertical vectors. So anything that's like 30 degrees north or 25 degrees south, whatever, will have a east-west and a north-south component to it. And that's where the algebra comes in. Shorthand's going to come in and I'm going to be moving off the slide. Good thing it's being recorded. So that kind of sub bullet point where it says instead of A, B, and C in A squared plus B squared equals C squared, we substitute the displacement values. I don't want you to be confused by instead of A, B, C. All we're doing is we're substituting components of a triangle. Then we can also find the angle of the resultant vector using the tangent function. which will often be the inverse tan of opposite over adjacent. The little slant here, I'll use the cursor. I'm using kind of a slant because I can't do a proper looking fraction where one is on top of the other. So it's opposite over adjacent, or delta D2 over delta D1. As usual, as I've mentioned before, it's a good idea to read through the chapter, even just kind of skimming. It's almost always kind of fill in a little bit of a blank or something. And sorry for those of you who wanted to look at the lesson yesterday. I got distracted. As soon as I end a Zoom meeting, it won't start converting the file until I end the Zoom meeting, and then it takes 10 or 15 minutes to convert it. And then I get distracted. People come into my office. People are usually Mr. N's. Comes, puts his feet on my table, acts like he owns the place. Speaking of people who own the place, good timing. I have some bad news for you, Ada.
Yeah.
I'm not waiting till you take all this down, but it is being recorded.
Okay.
And the really important parts will be the actual doing.
Is this
So,
the first slide?
yeah. Kate, you still writing? Ben? See, yeah, little.
I'm done.
Oh, you're done. Success, you're good? Everybody's good? Cool beans. All right. So have a look at the practice on page 67, but here's also this figure on page 67. You know, I'm going to blow this up. Not on social media. I just meant bigger. That's not very big at all. Anyways, so this is on page 267 if you want. So when you are, let's say we go kind of, you're given something that's north or south, and something that's east or west, you can just put them together. This is just a squared plus b squared equals c squared. This is kind of the easy version. So we're going to solve for this. This is one part of our answer. And that's what we were doing yesterday. We drew, and then we figured out what was the connector. So that's part of our answer. And now, oh, and to get that, now with algebra, we do it this way. A squared plus b squared equals c squared. But we also need that angle. So it's the inverse tan of opposite over adjacent. There's an angle component, there's a vector component, and this will give us our final answer. Relatively straightforward, or am I going too fast? What do you, I couldn't tell that. Was that like,
Oh, no,
this
it's fine.
sucks,
It's
or is
good.
this like, this makes no sense, or I hope I never get that bald spot. Wait, was it one
No,
of
it's
those?
fine.
two?
I
Okay.
have the video, so I'll be fine.
Cool. Questions from anybody? Anybody else thinks this is a hole in the screen and there's light coming from the other side, or is that just the way my brain works? All right, moving along.
Nice transitions.
Oh, it's beautiful. Some of the stuff I did, and then like some because I thought it would be funny, and so I made it like take a minute to translate. So like letters drop, and like, and then once you're in it, you can't get out of it until the transition's done. So dumb ideas at the time, but anyways, I'll just put it all out there so you can write it down. I guess there's gonna be one more page after this. What's that?
You can use my laptop if you need, and I can just send it to yourself. On my paper.
Would it help if I read it out slowly? Or even just once
Yes.
for clarity? Okay, I'll read the first paragraph and then first fast and then slow. In order to use the Pythagorean theorem, we need perpendicular vectors. If we don't have them, we need to make them. When I say make, we could almost say find them. So I'll say it again. In order to use the Pythagorean theorem, we need perpendicular vectors, period. If we don't have them, we need to make or find them. Next bullet point. Ada?
No, but you can go.
I feel like I'll just mess with people at different places if I read it out. So what happens if we don't get like a perfectly vertical or perfectly horizontal line? It's as if we're given the hypotenuse and an angle. From that, we need to get the opposite and adjacent, which will be the vertical and the horizontal components. You'll do that with sine or cosine. And we're gonna do that for any vector that is not perfectly horizontal or vertical. We want to add two vectors like this. We'll be adding their component parts. Figure 4 on page 68 is on the next page, so we'll talk about that. There is practice on page 69. Ada, let me know when you're done, please. By the way, somebody please remind me to mention this in pre-cal. Tomorrow, I'm needed in another SLG, so math will start just a little bit after 9. Moments, but not right at 9. Just so you know. Pardon, eh? It used to be pre-cal was like first thing in the morning every day. I would rather that. The afternoon, my brain starts going to mush. Last period, how does anything get done in that period?
Yeah.
For anybody?
Not much. Not much. Ben,
I think Mr. Janenga used to say the best period of the day was B slot to teach and to learn. I know when I have morning spares, that's when I get my best work done. Afternoon spares, I get on YouTube and what's that?
just tired of doing stuff.
Yeah, just put my feet up and watch YouTube or something. How's it going over there, Ada? Oh, I got the thumbs up, ladies and gentlemen. We can move on. So now what's going to happen? So you can follow along in your textbook if you want, because this is terrible looking. But I drew to sneeze. So you have, this is the original vector you're given. You're given this black vector and this black vector, and you said, and you're told, okay, add these two bad boys. So what you first need to do is figure out the horizontal and vertical component of each. Now notice with these arrows, I don't know why I'm using this because I'm not using it. Notice this says over here, we're adding up the horizontal vectors. So we're taking this one and this one, we're adding those together. So now we've got a big vector that's horizontal. We're taking this vertical and this vertical, we're adding them up. Now we have this big one. Now we're taking these two that we combined, we're putting them together to find the resultant vector. So this red one is the result of this black one and this black one. Did I lose anybody anywhere? And we'll do this, so you'll see. Really hope we don't run out of time. Yep.
This, okay, never mind. You can just-
No. I wasn't saying that to someone else. If you got questions,
No,
ask them.
this makes sense, but like, I was gonna ask like what context we would like use this in and like word equations, but it's, might take a while.
You'll see right away, but like, if I walk to 7-Eleven for, how far is that? 500 meters, south 10 degrees east.
Yeah.
And then I go to my friend's place that is 67 meters.
Oh, this is
East, 4
finding the
degrees.
displacement from the school to the house.
Yeah.
Okay,
Yeah.
okay.
So then you got this, and then once you got this, you got to get the angle. Well, and like you figure out the red with Pythagoras because it's a squared plus b squared equals c squared, and then you solve the angle with inverse tan, opposite over adjacent. Bajinga. And I'll show you how we do it. But this is a really good summary, even though it might look a little crazy. We okay to actually try some of this? There's lots of examples for you to walk through, but I'm just going to do one to kind of get you started. Notice you only need to do odds because this takes some time. And the next unit is projectile motion, which is my favorite thing to teach. But unfortunately not the favorite for lots of people. What's that?
It sounds fun, but it probably isn't fun to do.
It's probably a mix.
When is the test for this?
Next Tuesday. We will have our last lesson for this on Thursday, this unit.
Like this week?
Yep. We have a new lesson tomorrow, new lesson Thursday. We're done. Monday study, Tuesday write. Barring something happening. Has everybody got this written down? 8 is good, so we're good. Where'd my, there she is. All right. Who's excited? This stuff is pretty cool. You know, if you're nerdy like me. Okay, page 71, number 2, it says a paper airplane flies 2.64 meters, 2.64 meters west, 26 degrees north. West, 26 degrees north. You don't need to write this out if you don't want to. I want it visibly there so I can reference it. Then it gets caught by the wind, which causes it to travel 3.21 meters, 3.21 meters. South 12 degrees east. South 12 degrees east. So we're going to draw these out. We don't have to worry about scale diagrams. So this is west, which is to the left, and 26 degrees north. So it does not have to be that accurate. Just you can give yourself kind of an idea. So it's going to be this. And this is 26 degrees. And maybe to help, I will show this goes, the horizontal is blue and the green is vertical. We have to solve the blue and the green. So that's for this bad boy right here. Over here, it's south and then east, so it's going to go this way, and it's 12 degrees. We need to figure out the horizontal part and the vertical part. And what's going to happen is we are going to add up those horizontal parts. Notice they're going in two different directions. So that is going to be a kind of a subtraction. Same with the vertical parts. So let's start with this. Here, this is 2.64. And this is 3.21. Please, please, please let me know the moment something doesn't make sense, because I tend to go kind of fast with these things. With everything, I go fast. Except driving. Too many speeding tickets. All right, so this side here is the adjacent side. We have adjacent and hypotenuse. So that's cos of theta equals adjacent over hypotenuse. So I'm going to put in the info that I know, and that is cos of 26 equals A, which is what we're solving for, over 2.64. Pull up my fancy calculator. Make sure it's in degree mode, depending when the last time was you used your calculator for anything. It's got a little D there. There's no way you can see that. Only math you can see that. So there's a little D there. If it has a G, that's gradians. If it has an R, that's radians. Neither of those. You'll use radians next to your gradients, not for a while, probably. So anyways, make sure it's in degree mode. So I'm going to hit cos of 26 equals that. And then I'm going to multiply it by 2.64. And that gives me 2.373. 2.373. Now, I'm not worried about sig figs right now. I'm worried about making sure I have accuracy in my answer. Any problems thus far? Okay, so the green, might as well stay on this one. I'm gonna, the green is the opposite side. Opposite and hypotenuse is sine. Sine of theta equals opposite over hypotenuse. It's unfortunate. Opposite, 0. Sine of 26 degrees, just taking what's given, equals the opposite. Maybe we'll do OPP just so we don't think it's 0. Opposite over 2.64. So the opposite side is sine of 26 times 2.64. Sine of 26 times. It is a decent idea as we go through this to not only obviously to write it out yourself, but to punch some of these things in the calculator to make sure you're getting the same thing. One of the extra bonuses is in case I make a mistake, you guys can say, Mr. Morris, I have a different answer, which is always the nicest way to say, Mr. Morris, you screwed up. But it's also good because then you know the right order of the keys, because for this calculator, I have to hit sign and then the number. The calculator that's sitting on my desk, I have to put the number in and then hit the function. I'm going too fast. Do we need a moment? Okay, slow down while you get that down. And then I'm going to get all the component parts for this bad boy too. And then I'm going to combine them.
After we find A and we have H, can we just like A squared plus B squared equals C squared?
We already have hypotenuse.
And we're looking for the green one, right?
Oh, I'm sorry. You're saying
If we
could-
have H and we have
Sure.
A, can we just?
Yep.
It doesn't matter how we find.
You
it.
could have, yeah, you could do 2.64 squared minus
Yeah,
2.3. Yeah, totally. You can. Yeah,
just making sure
Yeah,
it's the same
nope.
thing.
totally. Yeah, good question.
Okay. I'm good if you're waiting.
Yeah, if you're doing math the right way, it'll work out. Okay, I'm gonna stay with blue to get the horizontal. So this one is still the adjacent side. So this is gonna be cos theta equals adjacent over hypotenuse. Cos of 12 equals adjacent over 3.21. The adjacent side here, cos of 12 equals that times 3.21 equals 3.1399. The only reason I went to 4 decimal places is I didn't want to round my third one there. Something else you can think of and be aware of as you're doing the numbers. This should make sense. That should make sense. 12 degrees is a small angle. That means this, like, this is clearly not drawn to scale. 12 degrees would be closer to kind of like this, you know, this is more like 45. This would be 90, obviously. So 12 degrees means that this side is going to be longer than the green one. The green one's going to be short. Okay, so 3.21, as long as it's not bigger than 3.21, then we should be fine. I'm probably talking too much. So now the opposite side is sine of theta equals opposite over hypotenuse. Sine of 12 equals opposite side over 3.21. Sine of 12 is going to be a tiny number times 3.21, 0.667. So the opposite side equals 0.667. Oops. And it's small, but that's okay. It makes sense for this. 26 degrees is a relatively small angle. It's less than 45, which means the blue side here is going to be longer than the green side as well. 2.37, 1.1, blah, blah, blah. We okay so far? You okay if I start combining stuff? This bugs me, there's open space, but if I write in there, it'll be weird. So let's just do this. Okay, so for the horizontal or the x-axis, if you will, I'll just say horizontal for now. Horizontal, we have, notice this is going to the left. So we have 2.7373 west plus 3.1399 east equals, another way of writing that is just 3 point this minus this, right? We're finding the difference because they're opposing. They're going in opposite directions. Anytime I say the word opposing, I think of Muhammad Ali giving a speech on why he didn't go to Vietnam. I say a speech, he was talking to a news reporter. It's great. It's great stuff. 0.4026 east. Let's go green for the verts. Vertical. Used to be obsessed with my vertical. Used to be able to dunk. Yes. Yes, used to. Now I'm probably lucky if I can touch the mesh. Vertical. So the first one is going up, and that is 1.157. 1.157 north plus, and this one's going down, 0.667 south. I'm doing it with my north and south, east and west. If you want to assign a negative or a positive and stuff, that's cool in the gang. You know, you got to do what works for you. North, I'm going to do 1.157 minus 0.667. 1.157 minus 0.667, 0.49. 0.49 north. Can you see why I'm only doing one example? We're close though.
How many of these are we gonna have on the test?
like this, 1.
Mhm.
You want to hear a funny story? It's really short. When I first started teaching, I would get people to add 3 vectors. This is just 2. We don't need 3. Okay, are we good? Short hands, you good? I'm just gonna call you slow hands. Short hands, slow hands.
I think it's because I like think about everything and make sure I like understand.
That's good. It's not a bad thing.
All the notes.
It's not a bad
And so I
thing.
think that's why.
That's good. It's a good thing.
Just slow down the whole class. I swear, I don't think I'm the slowest one, but other people depend on me to say something.
No, you're definitely the slowest one. Because I also look around the room, and if it looks like somebody's writing, then I'll check in with them.
You know what? Someone told me in pre-cal that
Okay,
I'm not the slowest one.
that's nice. They lied. But here's the thing. I have a feeling this conversation is going to make it slower. Are you done?
Yeah.
Okay, so now I'm just going to add these 2 vectors. Okay, so let me try and put this so we can see everything. Okay, so, no, we can't. Okay, so my horizontal is east. So it's gonna go like this, and it's 0.4026. And my vertical is south, which is 0.49. Clearly, I was gonna say clearly it's not to scale, but actually those are probably pretty close. So anyways, we need to get this bad boy. So a squared plus b squared, try and stay on the sheet, equals c squared, 0.4026 squared plus 0.49. Richie, here. Can you pull the door shut, please? Thank you. That's okay. Yeah, just make sure, take it outside. All right, so root of 0.4026. I'm doing it kind of all at once, just for time's sake, sorry. Plus 0.49 squared. So equals 0.63. And this is a 2 sig fig question. Please say yes. No, it's 3. Get out of my life. Okay, 0.49634. Okay, 0.64 meters, centimeters. What is this? An ant? Oh no, paper airplane, meters. So that's the first part of the question. Now,
What?
first half maybe. Now we just need theta. I'll do it in black. We need the angle. Then we're done. Sorry, I'm keeping you. Oh, we have another 40 seconds. Okay. Tan of theta equals opposite over adjacent. The inverse, no. Theta equals inverse tan of opposite over adjacent. Opposite is 0.49.
Are we recording this?
Yeah.
Okay.
It's going to be really close to 45 degrees. 0.4026. Now, speaking of sig figs, the measurements are 3. The degrees are 2. So that's what we're going to do for this. Second, tan of 0.49 divided by 0.4026 equals 50 degrees. Therefore, final answer, the flag, sounds like I'm going to swear when I do that. The flying airplane, I don't know what it is. It's going to go, excuse me, 0.634 meters east, 50 degrees, 2 sig figs, I'm putting the decimal there, 50 degrees south.
Yeah. You done?
It's not the answer in the book. It's not even. Paper airplane flies in this, what is the paper airplane's total displacement?
That's just.
Okay, so what I'm gonna do is I'm just gonna end this meeting right here. I will go back